Okay. Now, basically, today we are going to learn about the balancing. Okay. We are going to learn about the balancing of redox reactions. Today we are going to learn about the balancing of redox reactions, right? Now, when we are about to learn the balancing of the redox reactions, so you should know that what are redox reactions? Redox reactions are basically oxidation
Yes.
as well as reduction, right? So basically those reactions in which there is oxidation as well as reduction is called as the redox reaction, right? Now, what do you exactly mean by oxidation? So there are 5 definitions of oxidation, right? The very first definition and the very basic definition was
Mhm.
the addition of oxygen. The addition of oxygen, right?
Yes.
Second is, Mummy, ye fan band kar do. Second is removal of hydrogen. So one is the addition of oxygen and another one is the removal of hydrogen. Now, another definition that comes is basically addition of oxygen or oxygen like species. So addition of oxygen like species, right? Now, what do you mean by addition of oxygen like species? Just understand. When we are talking about the addition of oxygen like species, you understand oxygen is atomic number 8. So the basic configuration is 2 6, right? And
Yes.
thereby, when the basic configuration is 2 6, it is going to gain 2 electrons. So when it is going to gain 2 electrons, what exactly happens? What exactly happens? You see that it requires a -2 charge. So just like the oxygen acquires a -2 charge in majority of its compounds, right? Similarly, chlorine. Look at chlorine. Chlorine is atomic number 17, and hence its configuration is 2 8 7. So it would like to gain 1 electron, and hence it becomes what? Cl-1. And when we talk about bromine, so bromine would thereby also become Br-1. Nitrogen would also become atomic number 7, configuration 2 5. So whenever the need arises, it gains 3 electrons and it becomes N-3. You understand?
Yes.
And when it becomes N-3, O-2, Cl-1, Br-1, so all of these species are more electronegative. And all of these species are thereby oxygen like. All of these species are thereby oxygen like. You understand?
Yes.
So all of these species are when oxygen like, right? So that is the addition of oxygen like species. Now, similarly, so if I say oxygen like species, by that I mean that anything which carries a negative charge. Similarly, when we are talking about the reduction, it would be what? Removal of oxygen. So I would complete this definition in one line: removal of oxygen or oxygen like species. So what are oxygen and oxygen like species? What are oxygen and oxygen like species? Oxygen and oxygen like species means anything which can remove, right? Removal of oxygen or oxygen like species, right? Similarly, what do we have? Similarly, what do we have? Addition of, reverse of it, addition of hydrogen or hydrogen like species. Removal of hydrogen or hydrogen like species. Now, what do you mean by hydrogen like species? What do you mean by hydrogen like species?
Oxygen like species.
Let's say, now what is hydrogen? Hydrogen carries a +1 charge,
Yes. Exact the opposite of
right?
oxygen. Redox
So
reaction.
anything which carries a +1 charge, let's suppose it is Na+1, Mg +2, Ca+2. So all the metals, right? All the metals which carry a positive charge, they all come under the category of hydrogen like species. So whenever in the reaction you see hydrogen being added or oxygen being removed, that is a case of reduction.
Yes.
Now these are certain basic definitions, right? Now there is one important definition regarding the same. That definition is about oxidation and reduction. Oxidation and reduction. In terms of what? In terms of what? Oxidation. In terms of what? Oxidation state. One, it is in terms of oxidation state, right? What do you mean by that? Increase in oxidation state. Increase in oxidation state of an element. Increase in oxidation state of an element in a reaction in going from reactant to product. In going from reactant to product. That is oxidation. And what is reduction? Decrease in the oxidation state of an element in going from reactant to product. Okay? In going from reactant to product. So basically, when we are talking about the reduction part, so the more comprehensive definition of oxidation and reduction is what? It is the increase in the oxidation state of an element in the reaction in going from reactant to product state. And what is reduction? Reduction means decrease. So that means the decrease in the oxidation state of an element in going from reactant to product, right? So that is the basic part. You understand? Now, so you just you learned how to calculate the oxidation state, if I'm not wrong, right? So you have learned how to calculate the oxidation state. And because you've learned that, now see how do we use that? So first you have to identify what is being oxidized and what is being reduced. Now let us suppose if I say NaCl plus KBr and I write down this reaction. So you see, I'll tell you why this method is better. NaCl plus KBr. So it gives you what? NaBr plus KCl. Now that's the reaction given to you. And they want you to tell whether it is a redox reaction or not. First, the question is this, that whether it is a redox reaction or not, right? Now, how do we proceed with this? Just see. So we have Na plus 1 and we have Cl minus 1. Because you know that NaCl will break into its positive radical and will also break into its negative radical. Yes or no?
Yes.
Similarly, KBr will break into K plus and Br negative. Okay. Now, Na remains Na plus 1 and Br is NaBr on the product side. And on the product side, K remains K plus 1 and Cl remains Cl minus 1. Why is this happening? Because Na is a metal and bromine is a non-metal. Similarly, K is a metal and Cl is a non-metal. Yes or no?
Yes.
So when this is happening, what do you understand from this? You see that Na from plus 1 to plus 1. You look at sodium, Na. Sodium in the reactant state carried a plus 1 charge. And when it was about to react, it is still carrying a plus 1 charge. You understand? It is still carrying a plus 1 charge. Cl negative. Cl carries a minus 1 charge in the reactant side. As you see on the product side, Cl is still carrying a minus 1 charge. That means Cl negative is neither losing, neither increasing, nor decreasing its charge. Neither increasing nor decreasing its charge. You understand?
Yes.
So basically, what is this? Cl negative is neither increasing nor decreasing its charge. Which means what? Which means what? That it is neither getting oxidized nor getting reduced. And when nothing is happening, so according to, and same with Na plus also, Na plus is also neither losing its, increasing its charge nor it is
Because
decreasing its charge.
oxygen and hydrogen is not involved in the reaction.
Yes. K plus, you look at K plus. How does K plus work? So K plus increases and still remains K plus 1. And see, Br minus remains Br minus 1. That means there is no increase or decrease in the charge. And when there is no increase or decrease in the charge, what exactly does that mean? What exactly does that mean? Tell me. When there is no increase or decrease in the charge, what exactly does that mean?
Not a
That
redox reaction.
this is a non-redox reaction. This is a non-redox
Redox.
reaction. It is not a redox reaction at all. Why? Because the charge of none of the elements is increasing or decreasing. The charge of none of the elements is increasing or decreasing. You understand? So what do we say? That this is a redox reaction. This is not a redox reaction. So from here, first thing that we understand that double displacement reactions are not redox reactions. You understand? Double displacement reactions are not redox reactions. No matter what double displacement reaction you have, it is not going to be a redox reaction. Yes or no? Similarly, what do we have? So double displacement reactions are not redox reactions. That is one thing. Secondly, next you have a look at this equation. So let's suppose if I give you Fe plus 2 plus NO3 negative gives you what? Gives you NO2 plus Fe plus 3 plus H plus. Now understand, H plus is just to tell you that there is some acid being involved. There is some acid being involved here. You understand? So when there is some acid being involved here, so we say that it is H plus. You understand?
Mm. Mm.
But here when we talk about Fe plus 2, you understand? So then what happens? So Fe plus 2, if you see, in going from reactant to product side, right? In going from reactant to product side, what is happening? What is happening? In going from reactant to product side, what exactly happens? You tell me. That, ma'am, the charge of Fe has increased from plus 2 to plus 3. Now, it has two meanings, right? One, in terms of charge, if you see, so you'll say the charge is increased. The charge is increased, yes or no?
Yeah.
One is the charge is increased. Right?
Yes.
That is one thing. The charge is increased. Second thing would be what? That if you see at Fe, what is Fe doing in increasing the charge? It is kind of losing one more electron. It is kind of losing one more electron. You understand my point? You understand?
Yes.
So basically, one more definition of oxidation comes up. That whenever you see the charge increasing is because Fe plus 2 has lost. Fe plus 2 has lost one extra electron. So the loss of electrons. So how do I remember oxidation? That loss has O in it, and O for oxidation. So loss of electrons is called oxidation. Loss of electrons is called oxidation. You understand the point?
Yes.
Loss of electrons is called oxidation. Got the point?
Yes.
So whenever an element is seen to lose electrons, we call it as oxidation. Similarly, if I ask you this, if I give you the oxidation case, so Mg is neutral, right? And when it becomes Mg plus 2, so that means it has lost 2 electrons. So we say that what? That Mg is getting, what is this? Mg from 0 to Mg plus 2. So basically, what does this happen? That means Mg plus 2 electrons. So you see from 0 to plus 2, the charge is increasing. Yes or no? From 0 to plus 2, the charge is increasing. From 0 to plus 2, the charge is increasing. So what do we say? That oxidation has taken place. Yes or no?
Yes.
Oxidation has taken place. But you also see that Mg in going from 0 to plus 2 has lost 2 electrons. So that is the basic meaning of oxidation, right? Now, similarly, if I talk about what? If I talk about the upper equation, now have a look at this NO3. Now you first calculate the charge on NO3. What do we do? NO3, let nitrogen charge be X. In the combined state, oxygen charge is -2. So for 3, it would be -6 equals to -1. So X would be equals to what? -1 plus 6. So X would be equals to +5. Yes or no?
Yes.
So if here nitrogen is carrying +5, now let's calculate the charge on the product side, what nitrogen carries. So let nitrogen charge be X, 1 oxygen is -2. So for 2 oxygen, -4 is going to be 0. So X is going to be +4. X is going to be +4. Did you understand my point?
Yes.
So here the charge goes from +5 to +4. That means it is reducing. Why? The charge in going from reactant to product is reducing. So it is going from +5 to +4. Yes or no?
Yes.
You understand my point?
Yes, I understand.
And thereby you understand why is the charge reducing. Let's suppose if I say that Fe plus 2 becomes Fe neutral. How do you think that any positively charged ion would become neutral? Only then when it is going to gain 2 electrons. So Fe plus 2 will gain 2 electrons and hence form what? Fe plus 2 electrons will form Fe neutral. Yes or no?
Yes.
So what is this? This is Fe plus 2 electrons will be Fe. Are you understanding my point?
Yes.
So what exactly does that mean? Tell me. That gain of electrons, if loss of electrons is oxidation, gain of electrons would be
Gain of no, gain of electrons
reduction.
should be okay. Yeah.
Because if anything gains electron, it is kind of gaining negative charge.
Yeah.
So let's suppose if I say Fe plus 3 converts to Fe plus 2, let's suppose that happens. What is happening here? Tell me.
Reduction.
Fe plus 3 to Fe plus 2, what is happening?
Oxidation.
It is gaining one more electron, not oxidation. In
Reduction.
going from reactant to product,
Yeah. So
the
getting
charge is
reduced
decreasing. Yes, the charge is decreasing. Why is the charge decreasing?
because an electron is there.
Exactly. So it is going from Fe plus 3 to Fe plus 2. Are you understanding?
Yes.
And when it goes from Fe plus 3 to Fe plus 2, that is a gain of electrons. You understand? So you understand that one electron carries a -1 charge. So the net charge of the reactants becomes what? +3 -1. That is 2, no?
Yes.
Because if you add the charges, the electron carries a -1 charge and Fe is carrying a +3 charge. So the net charge would amount into the products. Yes or no? Got my point?
Yes.
Yes or no?
Yes.
The gain of electrons would be reduction. Are you understanding? So the two new definitions of oxidation and reduction would be gain of electrons would be reduction and loss of electrons would be oxidation. Whenever there is a gain of electron, you have to see that the charge would be seen decreasing. And whenever there would be a loss of electron, you would see the charge or the oxidation state in going from reactants to product to be increasing. Any doubts in this, Tatu? Any doubts?
No.
Okay. Now just see. So if I give you this equation, if I ask you to balance this equation now. So first you have to identify whether it is a redox reaction or not, because all the double displacement reactions are not redox reactions. So it says balance the equation. And when it says balance the equation, it says balancing the equation in the acidic medium. The first method of balancing is in the acidic medium. You understand my point?
Yeah.
So now what happens? Let's suppose if I give you Fe plus 2 plus NO3 negative, if it gives you Fe plus 3 plus NO2, you understand? So here nitrogen has to carry a certain charge. So when nitrogen carries the next charge, so you just calculated that nitrogen's charge or oxidation state was plus 5. You understand? And here it is charge is going to be plus 4. So if it moves from plus 2 to plus 3, the charge increases. Yes or no? So when charge increases, it is oxidation,
Oxidation.
right? It is oxidation. Increase in charge is what? Oxidation. And
nitrogen
from
is
plus
getting
5 to plus 4, it is reduction. Also keep in mind what is happening. Tell me that plus 5 to plus 4. Understand? Plus 5 to plus 4. What do you think is happening? When you're moving from plus 5 to plus
one
4,
electron is going towards iron.
right? Now, when two things are attracting, see, when two things are reacting, understand? Fe is kind of losing one electron. You understand? Fe is losing one electron to become Fe plus 3. And that one electron is actually gained by NO3 negative. That's how it is changing its charge from plus 5 to plus 4. I hope you're understanding. So one reactant loses electrons, so the other reactant gains electron. You understand? So one reactant loses electron and thereby one reactant loses electron and thereby other reactant gains electron. You understand our point?
Yes.
One reactant gains electron and one reactant loses electron. Simple. So what do? You separate the oxidation half reaction. OHR is oxidation half reaction. So you write it down. Fe plus 2 becomes Fe plus 3 and one electron is lost. And reduction half reaction becomes what?
Fe3 plus E will turn into Fe or this one.
E is one electron because Fe converts itself to Fe plus 2 and one electron is lost. So basically you have to understand that one electron is being emitted out of Fe plus 2. So for me in that reaction, it is coming out as a product. NO3 negatives becomes what? NO2. And how? Because by it gains one electron. Because nitrogen was plus 5 and here in the product side it became plus 4. Did you understand the point? Yes or no?
Yes.
Any doubts in this?
No.
Got the point?
Yes.
And now when you add this up, what do you get? One electron cancels one electron.
Yes.
Now understand. Now oxidation half reaction. So there is an order. I call it as ACOH order. What is ACOH order? First you balance the atom. Which atom? In which the oxidation number is taking change. In which the oxidation state is actually changing. So one is called as the atom. One is the charge. Next is oxygen. And fourth is hydrogen. Did you understand my point? So one is an atom, one is a charge, one is oxygen, and one is hydrogen. Did you understand my point? Did you
Yes.
understand my point?
Yes.
So when we are talking about atom, charge, oxygen, and hydrogen, right? So in the oxidation half reaction, you see, I can see a change in the charge of iron. So that is one atom on one side, another atom, one atom on the other side. So iron atoms is balanced. In the reduction half reaction, what am I doing? First, I have to balance the atom. So I can see a change in the charge of nitrogen. Nitrogen's charge is changing from plus 5 to plus 4. So I would say on the reactant side, there is one nitrogen. And the other side, it would be another nitrogen. You understand?
Yes.
Did you understand?
Yes.
Any doubts in this? So nitrogen will carry a +5 charge and then +4 charge. Now the charge means the electrons. You understand when we are talking about the charge, so one electron is lost here. One electron is lost here. So one electron given off by Fe+2 is actually being accepted by NO3 negative. So when one electron is being given off by Fe+2, it gains one electron. NO3 gains. So basically charge is also balanced coincidentally. Now first equation does not have any oxygen. So I will not balance oxygen in the first equation since there is no oxygen atom. I would kind of balance hydrogen. But in the second equation, I have oxygen. I'll balance that first. Now, in the acidic medium, it's very simple. You understand. On the other side, so let's take a case here. Let's suppose we have, on the reactant side, we have 3 oxygen. And on the product side, we have 2 oxygen. You understand? Right?
Mm.
So on the reactant side, we have 3 oxygen. And on the product side, we have 2 oxygen. So which side is the oxygen less? On the product side?
Yes.
So I have to increase the oxygens on that side. So what am I going to do? I'm going to add water. Why? Because one water molecule has 1 oxygen. So let's suppose one side, if I would have AO and I would have AO5, let's suppose something like that, and I need to balance the oxygen. So in this random AO and AO5 equation, I can see then the reactant side, 1 oxygen is there, and on the product side, there are 5 oxygens. You understand my point? You understand my point?
Yes.
So here 4 water molecules would be there. Did you understand?
Yes.
Why am I adding 4 water molecules? Because every water molecule has 1 oxygen in it. Did you understand?
Yes.
So the rule says that you have to balance oxygen with water. You have to balance oxygen with water. Yes or no?
Yes.
And then you see there was no hydrogen in the picture. But because you added water, because of that 2 hydrogens came up. And those 2 hydrogens, if you see, you're going to add on the product, on the reactant side. So what is the rule to balance in the acidic medium? Balance the oxygen atoms by water. Okay. And hydrogen atoms by H plus ions. Simple. That's the rule. I hope you're writing them. So balance the oxygen atom by water and hydrogen atoms by H plus. Did you understand?
Yes.
So how does it work about? The 2H plus, 2H plus. You understand? So my final equation is, once you add the 2 equations, the oxidation half reaction and the reduction half reaction. When you balance the oxidation half reaction and the reduction half reaction, you get what? You get Fe plus 2 plus NO3 negative plus 2H plus will give me Fe plus 3 plus NO2 plus water. That is the equation. You understand my point? So that is the equation. You understand my point?
Yes.
You understand? That is the concept. So Fe plus 2 plus NO3 negative plus 2H plus gives me this part. Did you understand my point?
So you're just supposed to
Awesome.
add H on one side and water on the other side.
Yes, reactant side you add to reactant side and product side you add to the product side. And water with, why did I add water on the product side? Why did I add water on the other side? Because there is 1 oxygen
Due to
short on the product side. So one oxygen I can bring in the picture by adding one water molecule. You understand my point?
Yes.
Any doubts in this? So that is the concept. Okay? Yes or no? Now, let's suppose if I give you another equation. Let's suppose if I give you, let's say, Cr2O7 minus 2 plus PO3 negative to give me Cr plus 3 plus PO4 negative 3. Now, that's the equation that is given to me. And they have written H plus either of the sides to just let me know that it is an acidic medium, so that I follow the rules of balancing a charged or a balanced equation in the acidic medium. So let's suppose this is a hypothetical equation where you have to balance this equation, right? Now, how do you do this? The first step is to calculate the oxygen states. See, you
You have to add
understand
oxygen. Yeah.
oxygen's rule, I know. So all the equation, oxygen charge would be -2 always. So oxygen, I do not have to calculate. I have to
Uh, you can make it.
oxygen I have to calculate to be equals to what?
It should be equal on both sides. It's 3 on this side and 4 on that side.
So what I'm trying to tell you is that chromium's charge would be thereby.
It'll be 7.
Right. So basically, what did we have? We had this equation, right? So we had Cr2O7 minus 2 plus PO3 minus 3. And it gives you what? Cr plus 3 plus PO4 minus 3. Now that's the equation. And they have purposefully written H plus to tell you that it is an acidic medium. So let's start with the calculations, right? So here chromium is going to be what? Chromium is going to be X, right? So if I say chromium is going to be X, so for 2 chromium, it is going to be 2X. For 1 oxygen, it is -2 generally. So 7 oxygen will be -14 equals to -2. So 2X would be equals to 12. So X would be equals to 6. Did you understand my point?
Yes.
Next is what? Phosphorus is going to be charge X. So for 1 oxygen, it is going to be -2. So for 3 oxygen, it is going to be -6 equals to -3. So X is going to be +3. So phosphorus here is going to be +3. Yes or no? Here chromium is going to be +3. And here phosphorus is going to be what? X minus 8. Because every oxygen is -2. So 4 oxygen will be -8 is -3. X is going to be +5. So here phosphorus carries a +5 charge. And here 1 chromium gets a +6 charge. Now you understand the basic rule. Why am I calculating all of this? See, whenever a reaction takes place, the old bonds break. The old bonds break. Right? And new bonds are formed. And new bonds are formed. And whenever this is happening, that the old bonds are breaking and the new bonds are being formed, understand that when old bonds break and new bonds are formed, right? Whenever this happens. So when Cr2O7
Yes.
minus 2 radical breaks, it is giving itself with 2 chromium and 7 oxygen. It is giving with itself 2 chromium and 7 oxygen. So when it is giving with itself 2 chromium and 7 oxygen, that means every chromium comes out with a +6 charge. And every oxygen comes out from this radical with a -2 charge. Later on, they might rearrange, right? Similarly, when PO3 minus 3 radical breaks off, it gives me what? 1 P and 3 oxygen atoms. So 1 phosphorus carries a +3 charge and then -2 and then -2 and -2. So it is all about breaking. The old bonds have to break first. Do you understand the point?
The old
Yes or
bonds
no?
break.
Yeah. The old bonds,
Yes.
the old radicals and the reactants, they break. Only then they can rearrange, right? and then they form the products. So in that
Yeah.
rearrangement, some might lose electrons, some might gain electrons. But what is the initial state of Cr2O7 atoms? That if it breaks into two chromium ions, it brings with itself two Cr plus 6. And then it goes into the product side. Do you understand? Where chromium is carrying a plus 3 charge. So that is the basic meaning of it. So you have to remember and understand this concept, because if you forget this, then what is going to happen? Just see. So we have this part, right? So when we are talking about this particular part, just have a look. So what do? We say plus 6 to plus 3, right? Plus 6 to plus 3 and plus 3 to plus 5. So basically phosphorus is getting oxidized, because increase in oxidation number is oxidation. You understand? And plus 6 to plus 3 would be reduction. The charge is getting decreased. When does the charge gets reduced? Because of the gain of the electrons. Because of the gain of the electrons. Yes or no? Because of the gain of the electrons.
Yeah.
And where does the charge increases? Because of the loss of the electrons. So I'm going to separate the oxidation half reaction and I'm going to separate the reduction half reaction. You understand? Whenever I'm going to separate the oxidation half reaction, I'm going to say PO3 minus 3 converts to PO4 minus 3. That's my oxidation half reaction. And what is the reduction half reaction? Cr2O7 minus 2 converts to Cr plus 3. Yes or no? That's the thing. Again, we follow the rule ACOH. That ACOH is what? Atom, charge, oxygen, and hydrogen. Are you understanding? So when we are talking about atom, right? So first you look into both the equations. Now, whose charge are you finding change in? In the oxidation half reaction, you are finding change in the charge of phosphorus from plus 3 to plus 5. So basically, phosphorus atom is changing its charge, and there are only one phosphorus on both the sides. Hence, phosphorus atom is balanced. Next, we come to the state of Cr2O7, the reduction half reaction. We calculated that any chromium that comes out as a part of Cr2O7 is Cr2O7 Cr plus 6. You understand? So when it is Cr2O7 Cr plus 6, you understand? And it becomes Cr plus 3. So when it becomes from Cr2O7 Cr plus 6 to Cr plus 3, I am seeing a change in the charge of chromium. Yes or no? I am seeing a change in the charge of chromium. But when I am seeing the change in the charge of the chromium, I am seeing that the two atoms are not equal. Here on the product side, there is one chromium atom, whereas on the reactant side, there are two chromium atoms. So the number of atoms must be balanced. So what am I going to do? I am going to first balance the atoms. So I'm going to put a 2 on the product side, because that's the rule 1 of balancing. Always balance the atom and charge. Now just have a look. Now what is happening? One phosphorus is carrying a plus 5 charge, plus 3 charge. And when it goes to the product
Yes.
side, it becomes plus 5 charge. That means when PO4 breaks off, it gives me a phosphorus with a plus 5 charge. And when PO3 breaks off, it gives me phosphorus with a plus 3 charge. That means in going from reactant to product, phosphorus is doing what? What is phosphorus doing? Phosphorus is kind of doing what? Is going to lose 2 electrons. That's why P plus 3 becomes P plus 5. Are you understanding? That's why P plus 3 becomes P plus 5. Got my point? And similarly, when we are talking about Cr2O7 minus 2, you have to understand that one chromium is carrying a plus 6 charge, and on the product side, one chromium carries plus 3.
It loses total electrons.
So in all, how much electrons
3
will it
electrons
gain?
per chromium.
3 electrons per chromium ion. That means one chromium becomes plus 6 to plus 3. That means it has gained 3 electrons. And then another chromium, because there are 2 chromium on the reactant side, they also gain 3 electrons, and hence it becomes Cr plus 3. So that means what? That means what? Tell me. That means I would say that it has gained overall 3 and 3, 6 electrons. So if I provide 6 in all electrons to the radical Cr2O7 minus 2, you understand? It becomes 2 Cr plus 3. It becomes 2 Cr plus 3. Yes or no?
Yes.
And then what happens? This is going to multiply with 4. Multiply with 3. Because first we have balanced the atoms, right? Now the task is to balance the charge. So I'm going to multiply this with 3. I'm going to multiply this with 3. So my oxidation half reaction becomes what? My oxidation half reaction becomes what? 3PO3 minus 3 gives me 3PO4 minus 3 plus 6 electrons.
Yes.
And my charge in the reduction half reaction, RHR, would be what? 6 electrons plus Cr2O7 minus 2 to give me 2 Cr plus 3. Now, what does this indicate? It indicates that 3 phosphorus, 3 phosphite, PO3 minus 3 is phosphite, right? So it says that 3 phosphite radicals have lost in all 6 electrons. And because all of them have lost, because they are reactants, right? So the 6 electrons lost by phosphite are gained by Cr27. So 6 electrons lost by phosphite has been gained by dichromate ions. You understand? So charge has now been balanced. So you just have to look into the case that look at the electrons, right? Balance the electrons. How? That initially you had 2 electrons and you had 6 electrons. So the LCM of 2 and 6 is 6. So
Yes.
what do you do? 2 times 3. The answer would be 6. Got my point? And hence when you add it up, what do you get? Tell me. 6 cancels 6. And when you add, you get 3PO3 minus 3 plus Cr27. Now, without adding, before adding, the rule is atom is balanced, then charge is balanced. Then let's balance the oxygen. So rewrite the equations again. So my OHR again becomes, OHR balance becomes what? 3PO3 overall minus 3 becomes 3PO4 overall minus 3. Now let's balance the oxygens here. ACOH. A is done, C is done. O. Now on the reactant side, 3 times 3. We have what? We have 9 oxygen atoms. And here we have 3 times 4. That is we have 12 oxygen atoms. So when we have 9 oxygen atoms and when we have 12 oxygen atoms, what does that mean? What does that mean? 9 and 12. So I would say I have 3 oxygens short here. Every oxygen is to be balanced by water. So you write down what? You write down what? You write down 3H2O. You write down 3H2O.
Yes.
Right? And because you have introduced water, so I would say 6H plus. You understand my point?
Yes.
You understand? So you have balanced oxygen and you have balanced hydrogen in this particular oxidation half reaction. Now let's take an example of reduction half reaction. So reduction half reaction, again I'm rewriting it down. So that for me is Cr2O7 minus 2 gives me 2 Cr plus 3. Now how do I add it up? Now on the reactant side I have 7 oxygen and on the product side there is no oxygen at all, 0 oxygen. That means my product side is short of oxygen by 7. So to balance 7 oxygen, I'm going to add 7 water molecules. Because every water molecule will have 1 oxygen. So 7 such water molecules will thereby have 1, 2, 3, 4, 5, 6, 7 will thereby have 7 oxygens, right? And because I'm introducing water 7 times, I am kind of adding H. I am kind of adding H. You understand the point?
Yes.
And hence, what do we get? And hence, what do we get? I have to add 14 H plus. Did you understand?
Yes.
And hence, when you get the equation, add it up. So basically 3 water. So overall you added up 14H plus 3 water plus 3 PO3 minus 3 plus Cr2O7 minus 2. It gives me 3 PO4 minus 3 plus 6H plus 2 Cr plus 3 plus 7H2O. So you cancel water wherever it is extra. So 6H plus cancels and here you're left with 8H plus. 3 water cancels and here you're left with 4 water. Now the final equation that you have is 8H plus 3 PO3 minus 3 plus Cr2O7 minus 2 gives you 3 PO4 minus 3 plus 2 Cr plus 3 plus 4H2. That's your final balanced equation. So that's how the equation would be given to you. And if you know to balance such chemical equations, only then you can apply a higher advanced level of mole concept questions and equivalent concepts, right? So why am I teaching you this first? Because in order to solve the questions, the equation formation, the equation balancing, the redox portion has to be very, very clear. Only then you will be able to balance the equations and understand how equations are being framed. This is the longest part of chemistry. If you do this well, the entire chemistry becomes very easy and easy to understand and solve. Then chemistry is nothing. But if this part is difficult, and if you miss out onto this part and you do not practice it well, and all the various combinations, you might find questions which you might not be able to solve. So this part is a very crucial part of the chemistry, right?
Yes.
Any doubts in this?
Yeah, just what happened to hydrogen?
Hydrogen is balanced, 8H plus.
No, on the right hand side, it got cancelled.
Why it got cancelled? It's like transposing. So when you say 14H plus and you bring it here, you get minus 6H plus. So you're left with 8H plus. It's like that. Did you understand?
So initially there was a hydrogen over there. You brought it towards the other side.
Yes. What did I tell you? I told you that whenever you get this kind of question, right, they would simply write down H plus in either of the sides. It doesn't matter where the final H plus results into, where in what side you find the final H plus. But they might write down H plus on the product side or the reactant side, doesn't matter. Finally, the balanced equation. The purpose of this H plus is just to tell you that the equation has to be balanced in the acidic medium. And if this reaction is feasible, this would be feasible in the or being carried out in a acidic medium. That's the only purpose of writing down H plus in the equation. Nothing else. You got my point?
Yeah.
Right? Any doubts in this? So that's how you balance a chemical equation in the acidic medium. Right? That's the basic method. Next is, write down, balancing in the basic medium.
There was 14H because due to 7H2.
Yeah. Yeah. But when I added both the equations, my final product had 6H plus. And that 6H plus had to be cancelled out.
No.
Did you understand my point?
No, how did you get the 14 from 7H will become 14? Then you get 8.
Yeah. When you added, see, understand. When you added up the equations, right? When you added up the equations, what did you got? When you added up the equations, what did you got? You got 14H plus.
Yes.
And from the other side, you got 3H2. So this 3H2, after adding both the equations, I got 3H2 on this side. So I had this equation, right? And in this equation, you understand reactant 3H2O was there and the product 7H2O was there. How is it possible that one compound is present in both reactants and products, right? Either it will be a reactant or it will be a product. So wherever it is on the extra side, you cancel it out, right?
Yes.
So that's why. Similarly, how is it possible that H plus, 14H plus is on the reactant side and 6H plus on the product side? So you transpose it just like you do it in the mathematical equations. And when you transpose it, you get back to this. You understand my point? Any doubts in this?
No.
Right? That's how you balance the equation. Now, similarly, balance one more equation. Now, let's suppose if I give you this equation of C2O4 minus 2 plus MnO4 minus 1 gives me in the acidic medium CO2 plus MnO2. So that's going to be plus 7 and that's going to be plus 4. You understand?
Yes.
So how do we balance this? Just have a look. So first step is to calculate. So that's your homework, right? Try doing this question and let me know the answer.